Hi. What I'm going to do is talk about some of these invasive species, how we monitor them, what we're doing to sort of keep a track on what's happening and identify the next hot pest effectively that's going to play a part there. But just briefly, so you understand why I'm involved in that and what I may be able to add to the situation. I work exclusively for IBMA, which is the International Biocontrol Manufacturers Association. We are an industry trade association. We were established 20 years ago with 6 members. We now have around 240 members, so it's a fairly steep growth over that 20 years, which reflects the growth of the industry, because our industry is in fact growing at around 20% a year, which is quite an impressive growth when you look at the fact that the chemical industry is pretty static, maybe a 5% if that growth rate per year. So it's very much a changing of the times as to what we're seeing. We are a global organization, but we are very much European focused, and that's where we are concentrating our efforts, and our global members tend to have an interest in Europe and being involved there. We're a very diverse organization. We started off with many small SME companies. Recently, whether it's a good thing or a bad thing, we have had a lot of interest and investment in the industry from the conventional players. One could hopefully say that that's a changing of their attitudes, but some things happen at times and you think, is that really the case or is it not? So it's an open question at the moment as to what is the real intention of investment in our industry, and where are they heading to. Our members service the organic market. They also service, when I say they service that market, they produce biocontrol solutions to go into the organic market only, and others, and the vast majority, produce products that also, and services that go into integrated pest management, which in a way I think we probably need a new term for that now, because that in itself has been abused at times to justify very small moves of integrating non-chemical solutions into it. So we've got a very diverse organization. We're principally involved in agriculture and horticulture, but the members' interests are expanding rapidly into animal housing, home and garden, public health markets, because they're all important. They all need to have modern, effective solutions. So that's basically what the association is all about. The tools that the members supply currently, and I say currently because we are an innovative industry, fall into 4 different categories. The microbials, the viruses, bacteria and fungal pathogens, effectively that are coming mainly from out of the soil, natural things that have been observed to have an effect on plants, mainly on pests and diseases, and are then used to do that, to control, to be bred up and then released to control those same things. The macrobials, again, harvested from nature to go in there, and they've been observed to have an effect on various pathogens and insect pests, and hence, and weeds as well, and hence are being released to control those and being supplemented to other control methods. The semiochemicals, which are effectively communication tools. That the most well-known of those are the sex pheromones, but they have no effect on sex whatsoever other than communicating to the other sex of the same insect species that confuses them. So, and that's where these communication tools are there to mimic effectively what a pest species is anticipating. So there can be chiromones, things that are food attractants that are sending a signal that there's plentiful food over here, and you can combine those in a trap. The sex pheromones for confusing them, the aggregation pheromones for bringing them together, where you can treat them. And you can have some fairly innovative tools that if, for instance, you feed the aggregation pheromone into a nematode, you can end up bringing the pest to the control solution. So you can be fairly innovative. And the last group of current tools that are there are the botanicals, or the natural products. And what we're talking about there are extracts from plants, oils, different parts of plants that do have some effect, and again, from observation in nature. So it's very much using nature, which is a complex biological thing, to control nature, which is also complex and biological, not looking for the silver bullet that goes out there and controls something with absolute precision and destroys other things around it. We're trying to be as specific as we can and fitting into the system. So that's what our members are doing. Now on to the topic. What are we talking about? Why are these things invasive pests or invasive alien species? They're not coming from some other planet. They're coming because of change of situation here. They're coming, I put down two key drivers there. They're not the only drivers, but climate change definitely is having an influence on the plants that are growing, the disease spectrum that we're having, and also the insect and related pests that we're getting in there. Global travel also is another key thing, because people are traveling more. They're bringing things back with them, intentionally or unintentionally. And it's a thing, no matter how good our customs services are, we're not going to stop these things from happening. We will continue to have things coming across from other places, and I myself am an example that I'm not from Europe at all. I'm from Australia, so I'm an invasive alien species in my own right. So what form are we talking about? We're talking about plants coming in. We're talking about animals. Mainly, in this case, I'm restricting myself to insects, but it's not just insects. We've got aquatic species that are coming into European waters as the temperatures change, as the currents change, that we are getting things that come in. Birds, you've got little control over a bird, that they migrate themselves. They also bring things with them. We've also got pathogens coming in. So it sounds horrendous, but it is something we have to live with. If we concentrate on the weeds, what are we talking about? We're talking about weeds that can be invasive weeds from other regions, but we're also talking about things, and you're about to see an example from Dick when he follows me in his talk, where people originally brought a plant in because it was a lovely species, it looked good in the garden environment, and it was something that people wanted to have in their gardens. And that, when it's left unchecked, where it was in check in its native country, it becomes a weed in the European environment because it doesn't have the biological network that's there to keep it in check and keep it in balance in the ecology. It's not that it is deliberately a weed, it's the fact that it's in balance with things where it came from. It's no longer that way. What monitoring is being done by who and how? EPO I put down there because for weeds they have got this invasive alien plant panel that's keeping a very good track on the weed species that are a threat to Europe and where they're spreading, and looking at that mapping. So you've got the link there, so you can go on there and have a look at that because it's very good at that. It was set up to do more than that to start with. It was looking not only at weeds but across the board, and it's much better at looking at weeds where it's been concentrating on. If we look at fauna, and again I confine that to insects, we look at examples from agriculture. Tutor absoluta in tomatoes, that came from South America, and it was a huge pest in tomatoes in Europe. It is now under control. It was threatening to become out of control and be problematic. It is also something that's certainly a problem for people who are growing tomatoes in a home and garden situation. But there are biological solutions to control that adequately. A lot of very good macrobial species to control it, plus also the pheromones for monitoring and for control. Drosophila Suzukii, that pest at the moment is the big agricultural pest that's come in, and it basically decimates production areas of soft fruits in Europe. It's been particularly problematic in Italy, where it's been there. And what is so different about that? Most fruit fly pests will cause problems to fallen, damaged fruit. This one doesn't. It's got an ovipositor with a nice set of rasps on it, which I tried to put the picture there and it wouldn't go there, but it's very beautiful the way it does it because it actually has these serrations and can cut into intact fruit. And that's a big difference between the normal sort of fruit flies. So again, most people have got some fruits in their garden that would be possibly attractive to Suzuki because it is not at all specific with the types of fruit that it does try and attack. And so it again is being gradually, we're getting it under control, but what happens first, there's a big panic, and the first thing that's done is that there's emergency authorizations given for things like dimethoate to come back onto the market and to control this pest in cherries. And that's really decimates the whole of the ecological management that may have been in that cherry orchard before that. So you go back to step one, rather than what is the best thing that you could do, you should be there and trapping it, firstly to monitor whether it's come in, secondly to control it. And there are traps. At this stage, the pheromones are being developed, but there are food attractants that do attract this pest. So that would have been my first step towards controlling it, not going and reaching for the dimethoate as the first thing. But that's what happened. Public areas, we've got Camararia, which is the horse chestnut leaf miner. We've got oak processionary moth. We've got zebra mussels, which are being problematic in water reservoirs now across Europe. So there are things there. Public health, the vectors, we've already heard them talked about, but bringing in things like Lyme's disease, we are wanting to monitor where that's going, what's happening with it. Pathogen pests, I'll give a couple of examples there. Late blight and fire blight in agriculture, that's fire blight in that picture, which Winia does that sort of thing and also renders the tree pretty useless. Particularly pears, but also apples can be affected by it. Dutch elm disease was a very good early example of what happens in trees, ornamental trees in Europe, which very much wiped out a lot of elms across Europe. Monitoring systems. I put down a couple of examples here. In the US, they have been very proactive since 1999 in trying to predict what will go across Europe, across the US, cause problems, and coordinate the states in doing that. Also, they coordinate USDA, EPA, and other organizations within the US. So it's a very good tool. It's something worth having, and I've got the web link there for you as well. The same with EASIN, which the Commission established in 2012, which is a European alien species information network. So it's spreading information so that you end up with what is happening across Europe. That came about from the earlier work that was this toolkit of best prevention and management practices, which CABI produced. And that, again, is something that is very much worth looking at when you're looking at that side of things. If we look at monitoring and control tools, it all comes about from observation, observation and surveys. That used to be an onerous task. It was something that was organized by different bodies, universities, NGOs, different organizations that would do a survey on a particular time frame and get people engaged in it. It's now tended to be that we end up with a better system, albeit a lot more ad hoc at the moment, that we have got people reporting information and getting it out. That one of the tools, and Richard was talking to me about it, I think it was called iSpot, is the tool. You've all got these things, and if you go out there and take a picture of a different species that you see, and then it goes onto iSpot, and then you've got experts looking at that and identifying it, and they get points for identification and being backed up by other people in the identification. So it becomes a very rapid diagnosis tool and information network. So social media is certainly playing a part in how we're going to do this in the future. With the tools, what have we got? Trapping systems work very well, particularly for invasive insects. We use attractants, semiochemicals, basic substances, things like vinegar, sugar solutions, etc. are quite common attractants for different pests. But they're getting smarter as well. That we're using prediction models to look at whether these things can spread, the climatic distribution that we're likely to end up with, how far it's going for a particular year, and so on. But we're also now developing smart traps where the trap actually communicates back to the model and feeds it into the information, and it's then made live to a network. So again, it's doing things smarter. That sort of thing is already being fed directly out to farms. So it's in the agricultural environment now. Then it's going on to the control. And currently, in Europe, we have this crazy dividing line with where we split things. And I work with the Commission a lot trying to move that, because insect monitoring is a very sort of different tool depending on the thing that you're monitoring it in. One crop, one environment that you're having it in is different to another, and the species of insect that we're looking at trapping is also different. So trap density varies tremendously in when you're monitoring. Then if you're trying to mass trap, you need different densities again, depending on those different parameters. And so it's not consistent as to where you would have the line. People start to invent things called mass monitoring, which goes partway along that line, but doesn't quite get to one end or the other. So you end up with, where do you cut off between monitoring, which does not need a registration under EU legislation, or monitoring, mass trapping, which does need a registration. So that's got to be sorted out. It's something we're working on, and I will continue to work on that, because it's one of the first tools that people should be, whether it's in a farming situation or a public health situation, you should be able to rely on ramping up from monitoring to mass trapping without doing anything else, because you would not need to register it. If you put a chemical in that trap, you would need to register the chemical. So it's not that the pheromone or the attractant is there, it's just that it's the only thing there. We also have, as we've seen today, physical and cultural controls, but we have biocontrol as well. And just to emphasize that point on the mass trapping and monitoring, that there, having spent my early days in Australia in the surf, there's no way I'd still be in the water there thinking that's a dolphin, I can tell you. I'd be out of there pretty quickly. So we do then, by using those traps, we have time to develop other tools, so we don't have to go back to putting on the dimethoate. We also have a ready-made upgradable solution with a known attractiveness for the pest, and it can be scaled up quickly. So with that, I thank you.
Thank you very much, David.